Hello and welcome to this lecture where we'll go into actually modeling out some scenarios. So you have seen an example in the lecture before where we've gone into customers and orders for ice cream, right? So we created a conceptual model, at least I showed it in the keynote, but here I'll show you practically what tool you can use to actually create it. And also we will go into another example that is a little bit more advanced, and then we'll create an ERD conceptual model based on that. And the tool we'll be using is lucidcharts. So we'll head into the browser now. So I'm in the browser and I've just searched for lucidchart. So go in here and you can sign up for free. And let's check a little bit in the pricing. Let's see here, pricing. And you can see for the free version, you can create free editable lucidchart documents, and you have 60 shapes per document. And that will be enough for this course, but if you're a user that uses this much more, then feel free to buy the individual one, or if you're a team, you can buy the team one. You can just look at what suits you the best. But when you're starting out and learning, the free version is good enough. I will close this down and head over to data modeling course demo here. So I have created a document here, and in this one we'll add some shapes. So first we can see the shapes here. I don't have anything with ERD, so I just search for ERD, and you can see here we have entity relationships, and we have a lot of UML stuffs. And as we're using the Krauss-Foot notation or the information engineering, then we only need this entity relationships. And yes, these are, I think, yeah, they are the same. Yeah, exactly. So I'm closing this down here, and you can see that, yes, now I can get this. So let's look into the example from, not this one, this is another exercise that we'll take after the first example. So I have slides here. So let's go into this example here. Load more pages. Yes. So this one, we have customer, and we have places, order, and then we have contents here. So this is what we want to recreate. So I will actually do like this. I will copy this one here, and I will place it in here. Can I do that? Paste. Yes, tilde. Yeah, here we can see the image. Okay, so let's recreate this diagram here, and actually we need something more than just entity relationships. Let's search for ERD again, and you can see, let's say UML entity relationship. I need this one as well. So here we need a rectangle that is the entity, and I will make it into the correct size, and then I'll just copy it. So I press the Alt button in Windows, and in Mac I press the Option button. So here I will have order, so these are my entities, and I will have product here. So you can see we have the entities, and now we need to create the relationship cardinalities between them. So here you can see there's a one and only one, and here's one or more. So I'll just drag an arrow here. So here I will remove this arrow and change it to, let's say, one or more, right? One or more. I'll click on this one, and I will change this side to one and only one, because an order cannot exist without a customer, right? So here there's a places. So I'll just double click here, and I can type places. So I give this relationship a label. And let's see, let's make it up a little bit. Oh, sorry, like this. Yeah, it could be a little bit neater like that. Yeah, looks good. So then I will take from order to product. And here I will change this one as well. It's one or many. One or many. And then we have here from zero or more. Yes, exactly. And then we just double click here and says contains. So this is how simple it is to actually create these conceptual diagrams when you have an idea behind it. So based on the business requirements. So you know that here you have a product can be contained in zero or more orders, because we could have products that is not ordered at all, but they are still products in our inventory. And we can have order that the order contains at least one product, or it's not an order, right? So here we have a conceptual entity relationship diagram. Good. So this is an example. And if you want to have this saved, you just right click here and you can export the selection, and you can choose to export it as PNG or SVG or something else. So I'll choose, for example, PNG, and you can see how it looks like. So it saved it here, and we can double click this one, and you can see this is the selected export, right? And then you can use this to paste into whatever document or presentation. So great. Now let's do this example here. This Pokemon example, let me copy this one so I can have it inside here. So design a conceptual, let me see if I can move it here so I have more space. So design a conceptual ER model based on the following information. Each Pokemon has a name, Pokédex number, types, e.g. fire, water, base stats, HP is health points, attack, defense, etc., and an evolution stage. Each Pokemon can belong to multiple types. Charizard is fire and flying. Each Pokemon belongs to a trainer. A trainer has an ID, name, and hometown. A Pokemon can battle another Pokemon, and the battle has a winner. Some Pokemon evolve into another Pokemon. So, if we get this type of problems, we should first define what type of entities we have. So, entities, let me see, like this. So, basically what we have, of course, we have a Pokemon entity. And this entity has several attributes. It has Pokédex. So this is the number. It's basically an ID for this Pokemon. It means it's actually a natural key. So Pokédex, name, we have name, we have base stats, and an evolution stage, right? But we can keep it like this first. So this is Pokemon. Actually, we won't use the attributes in the conceptual model. Instead, when we come to logical model, we'll be using the attributes. However, it's nice to just write out the attributes. So we'll have the entity and the attributes so that you know which type of things need to be an entity or not. For example, they say also that Pokemon has Pokédex number and types. Note that we have types. So that means that should be an entity by itself, because it can have several different types, right? So since it can have several different types, we cannot store it as a list. We need to have it as an entity by itself. We can change this one. So we type here, instead of Pokemon, we have type. And then when it's a type, you should note that what do we need here? We need to have some kind of ID, type ID, and we need some kind of type name. Okay, so this means that we can have Pokemon with several types. And what else do we have? We have a trainer. So each Pokemon belongs to a trainer, right? So we have a trainer entity, and the trainer has different things, and it has an ID. We could write like trainer ID. It has, what else does it have? Trainer ID, name, and hometown. And then we have Pokemon can battle another Pokemon, and the battle has a winner. Okay, then battle is actually an entity by itself. Let's see. Yeah, it's badly formatted. It doesn't matter. I will remove this later. But we have a battle entity, and the battle entity, we could have a battle ID. And we could have, like, the battle contains Pokemons, right? So we have Pokemon 1 and Pokemon. And then we have some Pokemon evolve into another Pokemon. So we have evolution. And for evolution, we have a base, we have evolution ID, we have a base Pokemon, and we have a evolved Pokemon. Okay. So these are a few entities that we have. So let's create them. And of course, you can create conceptual diagrams that look different, right? But this is one example of how you can create it based on this information. So it can look a little bit different. I will create entity here, Pokemon, and we will have an evolution here. We'll copy this one, and we will have a trainer here. And here we have a battle. And what do we have here? We have type. Okay, so a Pokemon has a trainer, right? So it has, or it belongs to a trainer. So it's either 0 or 1 trainers. So we have here 1. And for trainer, it has 0 or more Pokemons, or you can choose that a trainer should have 1 or more Pokemons. If the definition of trainer is that, yeah, you have to have at least 1 Pokemon, then you use this 1 or more. But maybe you're working in some kind of gym and you don't own a Pokemon, but you train Pokemon, and then it's okay that it has 0. It depends on the definition. So that's the business rules. Okay, so a trainer has 0 or many Pokemons. A Pokemon has types. Let's see. Pokemon must have at least 1 type, right? So it can have 1 or more types. Yeah, exactly. I want to have this. Oh, it's the wrong side. Actually, it's here. Yeah, this is weird. Let's see. None. This one. Okay, so this is this side because I started from here. It can have 1 or many types, and a type could have 0 or more Pokemons. 0 or more Pokemons. Like this. Oh, wrong side again. Let me see. This side. This is the right side. 0 or many. Like this, yes. And when it comes to evolution, what do we have here? A Pokemon may have an evolution, right? But it may not have an evolution as well. So it has 1 or 0. So you only need 1 here. And then an evolution so an evolved Pokemon must have 1 pre-evolved Pokemon, right? So this must be 1 and only 1 on this side. And then battle. So a Pokemon can have a battle. So this depends on how the business rules are. So here it says a Pokemon can battle another Pokemon, and the battle has a winner. Well, I forgot the winner here, but yes. So does this mean that it cannot battle more Pokemons at once? So if you... Or actually, it can battle many Pokemons. Yeah, it can, because you can battle one at a time, right? But then you battle finish with one, and then you can battle the next Pokemon. So it's true. We can have many here. So it can battle or it cannot battle. So 0 or many battles. So a Pokemon can be in 0 or many battles. And a battle can have... Let's say can have 1 or 2 Pokemons. So let's see, here now should be many as well. Let's see, 0 or many. Let me see, this one is in this side, 0 or many. Let me see, 0 or many. Or actually, we shouldn't have the 0 here, because a battle always involves at least 2 Pokemons, right? And here, for the Krauss notation, then we have 1 or more. So we have 1 or more Pokemons involved. And this is a many-to-many relation, so this must be represented with a junction table or a bridge table when we go into the actual logical modeling and physical modeling later on. So here you could also add the different labels here. So a Pokemon may have 0 or 1 evolutions. An evolution needs to have at least 1 and only 1 Pokemon. And then we have, let's see here, and so Pokemon belongs to 1 trainer or 0 trainer. It could be a wild Pokemon. A trainer has 0 or more Pokemons. Pokemon have 1 or more types. Pokemon can battle another Pokemon, can battle 0 or more Pokemons. Yes. So this is my conceptual model of the Pokemon. So we can save this one as well. Export selection to PNG. This is how it looks like. Okay. Great. So with this, you have seen me working in lucidcharts, and this is quite a nice tool for making conceptual diagrams and later on for making logical diagrams as well. So thank you for watching this video and hope that you learned a lot. So see you in the next one. Bye.